Development of set theory. Set theory is a branch of a mathematical logic that studies the set, which informally are a collection of a object. Although any type of object can be collected into a set, set theory is applied most often to objects that are related to the mathematics. The language of a set theory can be used to define nearly all mathematical objects. The modern study of the set theory was initiated by Georg and Richards in 1870s. After a discovery of paradox in Navier set theory such as Russell paradox, numerous axiom systems were proposed in early 20th century, of which the Zermelo-Fraenkel axioms are best known.
Georg Ferdinand Ludwig Philipp Cantor. Georg Cantor was a German mathematician. He created set theory, which has become a fundamental theory in mathematics. Cantor established the importance of one-to-one correspondence between the members of two sets, defined infinite and well-ordered sets, and proved that the real numbers are more numerous than the natural numbers. In fact, Cantor's method of proof of this theorem implies the existence of an infinity of infinities. He defined the cardinal and ordinal numbers and their arithmetic. Cantor's work is one of great philosophical interest, a fact he was well aware of. Cantor's mathematical work. Cantor's work between 1874 and 1884 is the origin of set theory. Prior to this work, the concept of a set was a rather elementary one that had been used implicitly since the beginning of mathematics. Dating back to the ideas of Aristotle, no one had realized that set theory had any non-trivial content. Before Cantor, there were only finite sets, and the infinite by proving that there are many possible sizes for infinite sets. Cantor established that set theory was non-trivial and it needed to be studied. Set theory has come to play the role of a foundational theory in modern mathematics, in the sense that it interprets propositions about mathematical objects from all the traditional areas of mathematics in a single theory, and provides a standard set of all axioms to prove or disprove them. The basic concepts of set theory are now used throughout mathematics.
Julius Wilhelm Richard Dedekind. Julius Wilhelm Richard Dedekind was a German mathematician who made important contributions to abstract algebra, particularly ring theory, axiomatic foundation for the natural numbers, algebraic number theory, and the definition of the real number. Richard Dedekind's mathematical work. While teaching calculus for the first time at the Polytechnic School, Dedekind developed the notion now known as the Dedekind cut, now a standard definition of the real numbers. The idea of a cut is that an irrational number divides the rational numbers into two classes, with all the numbers of one class being strictly greater than the numbers of the other class. For example, the square root of 2 defines all the non-negative numbers whose squares are less than 2 and the negative numbers into the lesser class and the positive numbers whose squares are greater than 2 into the greater class. Every location on the number line continuum contains either a rational or an irrational numbers. Thus, there are no empty locations, gaps or discontinuities. Dedekind's theorem states that if there existed a one-to-one correspondence between two sets, then the two sets were similar. He invoked similarity to give the first precise definition of an infinite set. A set is infinite when it is similar to a proper part of itself. In modern terminology, is equinumerous to one of its proper subsets. Thus, the set n of natural numbers can be shown to be similar to the subset of n whose members are the squares of every member of n to n square.
Aristotle. Aristotle was a Greek philosopher and polymath during the classical period in ancient Greece. Taught by Plato, he was the founder of the Lyceum, the peripatetic school of philosophy, and the Aristotelian tradition. His writings cover many subjects. including physics, biology, zoology, metaphysics, logic, ethics, aesthetics, poetry, theater, music, rhetoric, psychology, linguistics, economics, politics, and government. Aristotle provided a complex synthesis of various philosophies existing prior to him. It was it was above all from his teaching that the West inherited its intellectual lexicon as well as problems and methods of inquiry. As a result, his philosophy has exerted a unique influence on almost every work of knowledge in the West, and it continues to be subject of contemporary philosophical discussion. Aristotle's work. With the prior analytics, Aristotle is credited with the earliest study of formal logic, and his conception of it was the dominant form of Western logic until 19th century advances in mathematical logic. Kant stated in the Critique of Pure Reason that with Aristotle logic reached its completion. What is today called Aristotelian logic, with its type of syllogism, Aristotle himself would have labeled analytics. The term logic has reserved to mean dialectics. Most of Aristotle's work is probably not in the original form because it was most likely edited by students and later lecturers. The logical work of Aristotle were compiled into a set of 6 books called the Organon around 40 BC by Andronius of Rhodes or other among his followers. Thank you.
Set theory in mathematical education. As set theory gained popularity as a foundation for modern mathematics, there has been supported for the idea of introducing basic theories or naive set theory early in mathematical education. In the USA, in the 1960s, the new math experiment aimed to teach basic set theories, among other abstract concepts, to primary grade students, but was met with such a criticism. The math syllabus in European schools followed this trend and currently introduce the subject at a different level in all grades. Set theory is used to introduce students to logical operator and or and not and semantic or rule description of set theories. This may be useful when learning computer programming languages, as a set and Boolean logics are basic building blocks of a programming language.